Okay, in this video I'm continuing with problem 10 from the review sheet, the midterm review sheet, and it's this problem here. And I just did parts A and B, and now I'm going to use a private class A address space to assign the IP addresses to these hosts. And what's nice about the class A network is that it's got a lot of host addresses in it available. And in fact, with a Class A, we've got three different uh, uh, bytes with which to use to assign host addresses. That's plenty, and we can come up with a nice scheme. We're going to use 3/16 networks for our subnets, and so we're going to use the second byte of the IP address for to identify the subnet, that is VLANs 1, 2, and 3. And then we're going to use the third octet to label the switch number, and finally the fourth octet to label the host number. And this will work out nicely. And so for part C, it says provide subnet IDs for the three subnets corresponding to the first three VLANs, assuming no VLSM, variable length subnet masks, and that's already implicit in what's described above. Using this scheme, list the ranges of IP addresses used for the 6 sets of host machines given the table above. And part E, how many IP addresses are wasted when we use a Class A network for this set of machines? Well, a Class A network has 2 to the 24th host addresses in it, and we have nowhere near 2 to the 24th hosts here. So we are wasting a lot, but you may be able to do that. Okay, so for part C, what I'm going to do is I'm going to make 10.x.y.z, and x is going to label the VLAN, y is going to label the switch, and z is going to label the host. Okay, and I guess I'll just use VLANs 0, 1, and 2 for this. And on the switch, I'll number them 0 and 1. And on the hosts, well, we can't use 0 because that's going to be the ID of the subnet. I'll use 1, 2, and ... Okay? And so let's just make a new table. So I'll write down the subnet IDs of the three. 10.0.0.0 is the subnet, and this is going to be a /16 will be VLAN, the subnet for VLAN number 1. 10.1.0.0/16 will be VLAN 2's subnet, and 10.2.0.0/16 will be the subnet for VLAN 3. Okay? And I can do that because of the Class A network address just begins with a 10. You can use everything beyond that 10. Okay, so what are the IP addresses used? Let's make another little table. Switch 1, switch 2. Give ourselves a little bit more room here and have VLAN 1, VLAN 2, and VLAN 3. And assign these addresses now. So for VLAN 1, I'm going to go 10.0. Now this is switch 1, so the third octet is a 0. And I'm going to start with host number 1. And on switch number 1, I need to go for 12 hosts through 10.0.0.12. So ... the first and the last IP address. On switch number 2, I'm going to put a 1 in the third octet. Still going to be 0 and 10.0.1, and now I need 5 hosts. So I'm going to go 1 through 5 here. Okay, VLAN 2 is going to have a 1 in the second 10.1, and VLAN 3 is going to have a 10.2. And now I fill in the switch ID, which is a 0 for switch 1 and a 1 for switch 2. 0 for switch 1 and a 1 for switch 2. And finally, hosts 1 through, well, we only have 1 in, I have 6, 4, and 10. 6, 4, 10. So I have hosts 1 through 4, 1 through 10, 1 through 6, host number 1, 1 through 12, and 1 through 5. Okay, let's see here. What else do I need to do? So those are the IP addresses. The number of IP addresses wasted. So this is C and D, so this is part D. And part E, a class A network has 2 to the 24th addresses. And how many are used here? 7 plus 14 is 21, plus 17 is 38. So we have 38 used. And so the number wasted is equal to 2 to the 24th minus 38, which is almost 2 to the 24th. It's 16,777,178 if you do the calculation. Okay, so that's problem 10. This is a nice way of using a private class A. In a situation like this, you can take any IP address of any of these hosts, 10.x.y.z, and immediately identify which VLAN it's in by the second byte, which switch it's on by the third byte, and which host number it is by the fourth byte. Okay, hope that helps.